I'll just copy this data. Control C, and then I'll put this data in my origin software. This is my origin software. Then I will copy its name as well. Where is the wave number and where is the absorbance? So I'll put this over here. So this is my wave number. This is time in minute. The absorbance at different time interval. So I will write minute over here. You can copy paste or you can do it. What I am doing, the wave number is in nanometer, so I will write the nanometer over here. Okay, as we don't have to put any formula or anything, so we will select all our data and go to the line graph. Now the line graph, you can directly go from here or you can plot it like this, plot it from here. Okay, so we will directly go from here, the line, we'll select the line graph and it will draw a line graph for this data for us. Okay, one thing which let's delete this thing. One thing which we forgot, most of the time we forgot this thing, that whenever the wave number, as we know, it is always on an x-axis. You can use this, as the wave number is same, you can use the same wave number, or you can just directly set it as x. Okay, you can directly set the wave number as x-axis. In older version of the origin, you have to go like this one, select this one, right click, and then set it as x. But in newer version, you can just put the cursor over here and it will show you that what do you want to do. So just select x-axis if you are using the latest version or the newer version. So we have set our x-axis. We will select this and now we will go for the line graph. So after this, you will get this kind of line graph. What we have to do, we will first set our x-axis from 400. Okay. Over here we will go to the scale. On horizontal axis scale, we want to start it from 400 till 800. Let's see over here, 800. Okay. And the vertical axis or y-axis, we want to start it from 0 till 1. Apply and okay. So it will show us like this. So we can also do it till 750, but I think 800 is okay. Now what we will do, we'll select these and change its size to 3. Now this data, our data is at different time intervals, so we'll change the legend as well. Copy this and then paste it. so we don't forget what is where. 0 minute, then this is 10 minute. You can copy this and paste like this. Later on you can change this thing, that this is 10, this is 20, then this is 30 minute, 40, 50 and 60 minute. So this is my data. I'll remove this one. Okay. Now for publication purpose we need some changes over here, so we will change the x-axis as intensity or absorbance. The unit is arbitrary unit, so we will write it a dot u dot. This is our wave number. We will just delete this one, the numbers, and then we will change the line index. We will come to the line index, and in the line index for major ticks we will show none, and for minor as also none. Apply this and you will see that our major and minor ticks are removed. For x-axis, if you want to keep this minor line, it's okay, but most of the time in our papers or in our article, we don't take the minor one, so we will remove the minor one, but it is up to you what you want to do. Okay, apply this so it will remove the minor. Now we will go to the grid, as we want this graph to look better, so we will additional line, opposite line, and click apply and open. Okay. If you want to remove the frame from this, right click, double click, and then after double clicking it will show you this kind of text object frame box. So over here you just put none and OK. So the frame will be removed. Now what you have to do, first change this thing into Times New Roman, then your wave number, the default one is the Arial, so change everything to Times New Roman. As for the paper or for the article or for the thesis, we take this one is in Times New Roman. So now it looks much better. If you want to increase the size, you can increase the size. Normally we recommend the size as 28 over here, then 28 over here also. This one is not changed. We didn't press enter after changing, so change the size and then press enter, and this one as 26 or 24. This one also as 24. So you can put it like this. You can increase or decrease size. Is okay. So hopefully now you understand how to draw, how to plot your UV visible data into region. Now what we will do, we will export this graph. Right click on the graph, export graph. You can copy it directly or you can export the graph. So right click, then click on the export. The best format is TIFF, PNG or TIFF, whichever format you want. Both the formats are okay. I normally use the PNG, so give the file name. For example, I want to give is the UV vis spectrum all. Okay, and then wherever you want to save it, give the file path to it. So I want to save it on text in my document. So I'll go to the document and click OK. Whatever DPI, the recommended one is 300, but if your reviewer want or your journal need another DPI, then you can change it. But normally we use the 300 DPI. I'll go to then I'll open my document, and you can see over here we have the UV visible spectra of all as TIF file. So we will open it. So you can see a much better graph, a very good graph. Hopefully now you understand how to draw a UV visible graph. If you got some information from here, please hit the like button, and if you want more videos like this, please subscribe and hit the bell button so you can get the notification of the videos which I upload on my channel. Thank you and Allah
शेयर कोक वाली बोतल से QR कोड स्कैन करके ढक्कन पर दिया गया कोड व्हाट्सएप करें और जीते स्पेशल गिफ्ट्स।
Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about determining the equilibrium concentration or CE value. I got a lot of questions about how to determine or how to calculate the equilibrium concentration of your adsorption experiment. Actually, I have seen some videos on YouTube. People have determined the CE value, but I think that calculation or that explanation, determination of CE value is a little bit misguided. Actually, in those videos, they have determined the equilibrium concentration, not the equilibrium concentration, but the concentration from the absorption values. They have the absorption data, and then from that absorption data, they made a calibration curve, and then from calibration curve, they converted the absorption value into the concentration value. So that is not actually the equilibrium concentration. For equilibrium concentration, you should know that you have to determine the equilibrium time. Equilibrium time is basically the time at which the adsorption and desorption becomes become equal. that is your equilibrium time, and the concentration at that time will be the equilibrium concentration. So to measure the equilibrium concentration, you have to run time experiment. You have to run the time experiment. What is time experiment? You have to do the adsorption experiment. You have to do the adsorption experiment for a longer period of time. In our case, we run the experiment for 3 hours. In some cases, you can run the experiment for 24 hours, for 6 hours, 10 hours. It depends upon the performance of your material or the performance of your adsorbent, till what time it can adsorb maximum concentration. So in our case, as I told you that we run the experiment for 3 hours. So you can see over here, this experiment, I run this experiment with initial dye concentration. The dye which I used was RO16 dye. The initial concentration of that dye was 100 ppm or 100 milligram per liter. The other experimental conditions was dose was 1 gram per liter or 1 milligram per liter. At 30 degrees C temperature, we did it in summer, so the temperature was 30 degrees C, or our shaking incubator, we set the temperature at 30 degrees C. The volume which we used for the experiment was 20 ml with the mass 20 milligram, and agitation was around 150 rpm, revolution per minute or rotation per minute. And the adsorbent which we used was activated carbon. This activated carbon was activated with H3PO4. So we did the experiment. We took the reading at 5 minutes, 10 minutes, 15 minutes, 20 minutes. Till 20 minutes, the sampling interval was 5 minutes. After 20 minutes, our interval was 10 minutes. From 30 minutes till 120 minutes, our time interval was 10 minutes. After 2 hours, our time interval was 30 minutes. 150 minutes and 180 minutes. So in total, we run the experiment for 3 hours. We got some concentration for each time interval. Now we will calculate the QT value. You know how to determine the QT. QT is basically the adsorption capacity at time. Adsorption capacity at time. So this was our formula, C0 minus CT multiplied by volume divided by mass. So we will put this formula, C0 minus CT multiplied by volume divided by mass. As these values we will use throughout this formula, so we'll log the columns. Actually, this is in ml. So in liter, it will be equal to 0.02 liter, and this will also be equal to 0.02 liters. Okay, so this value is in liter and this value is. Okay, so now we'll copy this formula till the end, and then we'll calculate the removal. Our removal is equal to, or removal in percent will be equal to C0 minus CT divided by CT multiplied by 100 or 100%. So we'll put this formula. So we will put this formula over here. This will be equal to C naught minus CT divided by divided by initial concentration multiplied by 100. So this is this much percentage. So we'll copy this formula throughout. So percent removal or QT is almost same in this case. Now what we will do, we will plot a graph of percent removal or the QT, a scatter plot. We'll plot a scatter plot this one plot. This is basically the CE measurement. This is basically the CE measurement. Now you can see that with the time lapse, the removal was increased. This means that there is more adsorption. This means that there is more adsorption. But over here you can see that after 60 minutes, these lines straighten. There is no much removal. There is no much adsorption. You can see that these lines become straightened and there is no much adsorption. If there was adsorption, these lines, it can go like this, but it is going in straight line. It is going a straight line. There is no much adsorption. So we can consider this 60 minutes as our equilibrium time. So we can consider this 60 or 70 minutes as our equilibrium time. You can see over here that at 60 minutes, removal was 71%, then 73%, and till 3 hours, only 77%. This means that only 6%, 5 to 6% removal was done in next 2 hours. In first 60 minutes, maximum removal was achieved in first 60 minutes. Later on, this removal was only 5 to 6%. So we can consider 60 minutes as our equilibrium time. So we can consider this 60 minutes as our equilibrium time, that after 60 minutes, not much removal, not much adsorption or desorption. If there was desorption, this measurement or these values could be lower. The removal could be lower than this value. So there was not much adsorption or desorption after 60 minutes. So we can consider this 60 minutes as our equilibrium time. And the concentration at this time is our equilibrium concentration. Okay, this CT is basically CT at 60 minutes. So we can say that our equilibrium time is 60 minutes, and our equilibrium concentration or our CE value in this case is 28.04. So 28.04 milligram per liter. 28.04 is the equilibrium concentration. So this is our equilibrium concentration. Hopefully now you understand how to measure the equilibrium concentration. First of all, you have to run the time experiment for longer period of time. At the time where you get maximum removal, and after that removal, these lines become straightened. That is your equilibrium time. In our case is 60 minutes. After 60 minutes, you can see that the lines become straightened and there was not much removal. In first 1 hour, the removal was 71%, almost 72%. And after that, in 2 hours, it was only 5 to 6%. So we considered this 60 minutes as our equilibrium time, and equilibrium concentration was 28.04. So you will use this equilibrium concentration later on in your isotherms modeling and your kinetics. Hopefully now you understand how to measure the equilibrium concentration and how to measure the equilibrium time and equilibrium concentration. Thank you very much. If you still have some confusion, you can ask over here, or my email address is given. You can directly ask me. Thank you and Allah Hafiz. Bismillahirrahmanirrahim. Assalamu alaikum and very warm welcome to Dr. Saqib Khan Science Academy. Today we will learn about extension coefficient. Before this, we determine the optical density using UV visible spectrophotometer data, and the same data we will use to determine the extension coefficient. First of all, what is extension coefficient? Extension coefficient is also known as molar absorptivity or molar extension coefficient. It is basically the characteristics that determine that how strongly a substance or a species it absorbs light at a particular wavelength. It absorbs or it reflects radiation of light at a particular wavelength. So this is our extension coefficient. To measure the extension coefficient, we have the equation K is equal to alpha into lambda divided by 4 pi, where K is our extension coefficient or molar coefficient, while alpha is the absorption coefficient, lambda is the wavelength, and the value of pi we know that it is 3.141. So using this formula, we'll measure the extension coefficient. Then to measure the alpha, as I already discussed in my previous lecture, while measuring the optical density, alpha is the absorption coefficient. You can watch the optical density measurement in this video, and to determine the absorption coefficient, the following equation will be used. Alpha is equal to 2.303 into A. A is the absorbance divided by L. L is the path length of the sample or thickness of our cuvette. This is usually in centimeter. As we know, the extension coefficient is the measure of absorption of light at a particular wavelength. So higher the extension coefficient, it means that substance is more efficient at absorbing light at that particular wavelength. Let's go to our data and see how to measure the absorption coefficient. So we have wavelength and then absorbance data of our compound. In this case, we used RB5 dye, reactive black 5 dye, and take its absorption. So first of all, we will measure alpha or absorption coefficient. We know the formula of absorption coefficient is alpha is equal to 2.303 multiplied by A divided by L. Our length of cuvette is 1 centimeter. A is given absorbance at different wavelength. So let's measure the alpha. Alpha is equal to 2.303 multiplied by absorbance divided by 1, or the thickness in 1 centimeter. So this is our absorption coefficient or alpha value. The pi value we already know 3.1141. Alpha into lambda. We'll calculate the alpha absorption coefficient multiplied by lambda, which is our wavelength. This is alpha into lambda. So we'll measure alpha into lambda for different wavelengths. Then our formula is K is equal to alpha into lambda divided by 4 pi. Alpha into lambda we have this value divided by 4 multiplied by the value of pi 3.141. We will log this value to use it throughout the formula. This is our k value. So now we'll plot the k versus wavelength Now we will plot these values, the wavelength versus k value. Let's go to the line graph. Now we will plot these values in a line plot. This is our line graph. You can increase these values. You can also increase the size of this. It depends upon you what type of data you want. This is our k value. This is our wavelength value. And from here you can see that lambda max is at 602. At wavelength of 602, we have highest extension coefficient. So this is how to measure the extension coefficient using UV visible data. Hopefully now you understand how to measure the extension coefficient of your sample. Thank you very much. If you gain some knowledge from here, please like, share and subscribe to my channel. Thank you and Allah Hafiz. Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about first order kinetic model. What is first order kinetic model and how to plot the data into first order kinetic model. Basically, the first order kinetic model is the one in which the rate of reaction is proportional to the concentration of the reactants. Okay, the rate of the reaction is proportional to the, if there are more reactants, if there are high concentration of the reactants, then there will be, the reaction rate will be higher. If there are more if there is, the concentration of the reactant is more, the reaction rate will be higher. And if the concentration of reactant is less, then the rate of the reaction will also be decreased. So the rate of reaction is dependent on the concentration of the reactants. Okay. Now this is the mathematical expression of the first order kinetic model. Ln Ct is equal to minus Kt plus ln C naught. So from here, from this equation, we will calculate the K value and ln C naught value, or the initial concentration. We can calculate the initial concentration from this. We will plot, our plot will be ln Ct versus time. Ln Ct versus time. As we have the Ct value, we can calculate easily the ln Ct value. So ln Ct will be equal to natural log of the Ct value. Okay, copy this data, copy this formula till the end, and you will get the ln Ct value. Copy this data and paste it over here, and then we will plot this data into the origin. As I prefer to use origin for calculating for plotting the data. Okay, we will make a scatter plot. Scatter plot of this. We'll go to the analysis, fitting, linear fit, and then we will open the dialog box. In the dialog box of the linear fit, just click on OK, and the next dialog box, click OK. We have we got the intercept value and we got the slope values. So copy these values and paste it over here. So we have the intercept value and we have the slope value. As we know that our slope is equal to minus k. From here you can see that slope is equal to minus k. So the k value will be equal to, the k value is equal to minus multiplied by this value. Our intercept is equal to ln C naught. As from this formula, you can see that y is, if we, this is actually y is equal to mx plus c. Our m is our slope and c is the intercept. So our intercept is ln C naught. Okay, our intercept is equal to ln C naught, and the value of C naught will be equal to anti-ln of the intercept. So for anti-ln of the intercept, this is the C naught value. So is equal to x of the intercept. So this will give us the initial concentration. So our initial concentration is 30 ppm in this reaction. So it is almost same 29.5 or 30 ppm. So our initial concentration. So this confirms that our data is following the first order reaction. So it is both are almost same. Now in first order reaction, we also calculate the T half value. The half-life is the amount of the time it takes for half of the initial reactant concentration to be consumed or converted into products. So it is important in chemistry or in pharmaceutical industry or in medical industry. So the formula for T half is equal to 0.693 divided by K. So we can calculate the half-life is equal to 0.693 divided by the K value. So this is 86 minutes is the half-life of this reaction. Okay. Hopefully now you understand how to plot the data in first order kinetic model, how to calculate the order of the reaction, reaction rate, K, and how to calculate the half-life of the reaction. So our R square value based on the base is 0.98. 0.9800. This is our R square value. We calculated the R square for first order reaction, for pseudo first order reaction, and for pseudo first order reaction. So over here you can see that our first order reaction, the R square value is higher as compared to PFO and PSO model. So we can say that till now our model is following, our data is following the first order reaction. Okay, our model is following the first order reaction with half time of 86 minutes. 86 minutes. Okay, so R square value is higher for first order reaction, so we can say that our data is following the first order reaction kinetics, or first order reaction rate. Hopefully now you understand how to plot this data. Thank you very much. Don't forget to subscribe and share with your fellow students and colleagues. Allah Hafiz. Bismillahirrahmanirrahim. Assalamu alaikum and very warm welcome to my channel. Today we will learn about the optical density, how to measure the optical density from spectrophotometer data or the absorbance data. First of all, you should know what is the formula of optical density. Optical density is equal to alpha into L. D optical is optical density and alpha is absorption coefficient, while L is thickness of the cuvette which you use. This is normally 1 centimeter. The thickness is normally 1 centimeter. While to find out alpha or absorption coefficient, we have the formula that alpha is equal to 2.303 into absorbance divided by the thickness. This is, I have some data, some absorbance data, the wavelength and the absorbance data. So this is a sample data from which we will calculate the absorption coefficient, and then we will first calculate the absorption coefficient, and then we will find out the optical density at different wavelengths. So let's go to this. So over here is our absorption coefficient. Okay, the formula is, the absorption coefficient formula is 2.303 multiplied by absorbance divided by thickness. So let's write thickness over here. This is, thickness is 1 centimeter. So let's write the formula again, is equal to 2.303 multiplied by the absorbance and divided by thickness. So we will log this thickness to have the same reading below. So just double click over here and the formula will be copied all the way till 200 nanometer. Okay. So this is wavelength. Wavelength is in nanometer. Okay. So this is our wavelength. This is our absorbance. Absorbance value is arbitrary unit. So we'll write it as A and the coefficient. Now, as we calculated the alpha, we will calculate the optical density. Optical OD. Optical density. Optical density is equal to, as we know that in this formula, optical density is equal to A into L. So what we will do, we will write is equal to, this is our A multiplied by thickness is 1. We write it again, is equal to this multiplied by thickness. Okay, and double click this, this thickness. This thickness will be locked. Just putting the dollar sign before and after the column, it will lock that column. And this is the optical density of all this. Now you can put this into a graph in origin. Let's copy this data. Let's copy this and this, and we'll put this into the origin. We'll remove these two. We'll remove these two columns, and we have wavelength and optical density over here. Now just simply make a line chart, and this will give you the optical density of your sample at different wavelengths. So in this way you can find out the optical density of your sample. You can play with this, you can increase the width, you can increase the width, and so on. So this is the optical density of your sample at different wavelengths. For example, we want to know the optical density at 600 nanometer. So this is 600 nanometer. The optical density is 1.68. We want to know the optical density at 500 nanometer. So 0.64 the optical density at this nanometer. So hopefully now you have learned about how to calculate the optical density and how to plot it against different wavelengths. So the formula for optical density is this, alpha into L, where alpha is absorption coefficient, A is the absorbance, and L is the thickness, which is 1 nanometer. And put this formula, first of all calculate the absorption coefficient. First of all calculate the absorption coefficient by multiplying absorbance with 2.303 and divided it with the unit thickness. This will give you absorption coefficient, and then optical density is the absorption coefficient multiplied by thickness. This will give you the optical density. Then plot these two into in Excel and get this formula. Thank you very much. आपको समझ आ गई होगी. Hopefully you understand how to calculate the optical density from the observer state of spectrophotometer, and then plot it against different then plot the optical density against different wavelengths at different wavelengths. Don't forget to like, comment and subscribe. If you need any special lecture on a special topic, please comment in the comment section below, and I will try my best to upload those lectures for you. Thank you. Allah Hafiz. Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about Elovich adsorption model. The Elovich adsorption model, the basic assumption is to understand the chemisorption nature of the adsorption. So Elovich adsorption model is applied. We want to understand the chemosorption nature of the adsorption. And this model helps to predict the mass and surface diffusion. We can say that Elovich model is used to describe chemical adsorption and is applicable for heterogeneous surfaces. If we want to study the heterogeneous surfaces, then this model is applied. The equation for Elovich adsorption model, the linear form of this equation is Qt is equal to 1 over beta ln alpha beta plus 1 over beta ln t. This is simple linear equation y is equal to mx plus c, in which alpha is primary rate of adsorption while beta is desorption constant during each experiment. So from this equation we will calculate the value of alpha and beta. Our slope will be 1 over beta while our intercept is 1 over beta ln alpha beta. This will be our intercept. The x value ln t shall be plotted against Qt value. Qt is adsorption capacity at time. I have calculated the adsorption capacity at time in my previous videos where I calculated the PFO model. In PFO model, I calculated QT and QE. The formula for calculating QT is equal to C naught minus CT multiplied by volume divided by mass, or W. So this is our QT value. You can go to my previous video which I made on pseudo first order kinetic model, and I have explained this in detail. Over here I have just put the formula to calculate QT. So we run the experiment for 10 to 120 minutes. Our initial concentration was 30 milligram per liter or 30 ppm, while we calculated the CT value at different time intervals from 10 to 120 minutes with 10 minutes interval each. According to formula, our x-axis will be ln t. So we will calculate ln t first, and then we will calculate the y value, qt value. So for calculating ln t, we will take ln of the time value, ln of this. So this is our ln t value. Now we will calculate. Now we will put the formula for qt is equal to initial concentration minus final concentration multiplied by volume divided by mass. As in our case, I already told that our mass and volume was same, so we can just multiply it with 1, or we can just only do C naught minus CT. That will give us QT value. So this is our QT value. In the formula, this B11, these values shall be used throughout the formula. So we will log these values by putting $sign before and after. And then double click this one, the formula will be copied. So over here, we will plot ln t versus qt. Go to the insert. In the charts, select the scattered one, and this is our now we will make a trend line, linear trend line of this, and display the equation and R square value, because from this equation we will calculate the slope and intercept. So our slope over here is 6.5976, while our intercept is minus 14.347. So according to the formula, our slope is equal to 1 over beta, while beta will be equal to 1 over slope. So this will be equal to 1 divided by the slope value. Okay. Now from the intercept, we know that from the equation we know that intercept is equal to 1 over beta ln alpha beta. Our intercept is equal to 1 over beta ln alpha beta. If this beta value comes over here with the intercept, so this will be equal to intercept into beta is equal to ln alpha beta. Then this equation we can manipulate this equation, and intercept into beta will be equal to ln alpha plus ln beta. As we already have beta value, so it will be equal to ln alpha plus ln beta. And then our ln alpha will be equal to intercept into beta minus ln beta. So our first we will calculate the ln beta value. Our ln beta will be equal to ln of beta value, while our intercept multiplied by beta, our intercept multiplied by beta value will be equal to, we will multiply intercept into beta. So this will be equal to intercept multiplied by the value of beta. So this is ln alpha, this is intercept into beta. While our ln alpha is equal to intercept into beta, this will be equal to intercept into beta minus ln beta. So this is the value of ln alpha. Our alpha will be equal to exponent of the ln alpha value. This will give you the alpha value. So our alpha value is 0.749. Alpha value is 0.749, while our beta value is 0.15. As I told you that alpha is the rate. Alpha is the initial rate or primary rate of adsorption according to Elovich model, while our beta value is the desorption constant. So from here we calculated the primary rate of adsorption, and while our R square value is 0.9367. So our R square value is 0.9367. We use the data which we already applied for Langmuir adsorption model, for Framwich, for DR and Thumbkin isotherm model. So the same data we have used over here for Langmuir model, Framwich model, DR model and Thumbkin model. You can see my previous videos. I'll give the link in the description. This is all about Elovich adsorption model. Hopefully now you understand how to fit your data in Elovich adsorption model. If you got some information from here, please like the video, subscribe to my channel and share this video with other colleagues. Your like and subscription will motivate me to create more informative videos like this. Thank you very much and Allah Hafiz.
चिल गुजरे लाइफ सीना रहे ठंडा जैसे गले में हो स्प्राइट डालो मचा
Bismillahirrahmanirrahim. Welcome to Dr. Saqib Khan Science Academy. Today we will discuss about intraparticle diffusion. Before this, we discuss about pseudo first order, pseudo second order and first order reaction. As you know that the adsorption is a surface phenomenon. This means that the particles or the molecules that are adsorbed on the surface of the adsorbent. But you know that whenever there is some adsorbent, it may have intracellular spaces, and the particles may diffuse inside those intracellular spaces and can adsorb over there. In this figure, you can see that the intraparticle diffusion is a bit explained. The adsorbent molecules, the adsorbate, you can see that intraparticle spaces inside an adsorbent, and the adsorbate molecules, they can enter inside and they can adsorb onto the active sites. So this model explains basically the process of diffusion. The equation for this model is Qt is equal to KID plus T half or T underscore plus I. This is I. I is basically the thickness of the layer and K is the intraparticle diffusion constant. This model is also called as Weber-Morris model or and IPD, intraparticle diffusion, IPD model. Okay, let's write IPD. IPD model. Okay, so if you linearize this equation, y is equal to mx plus c, or y will be qt, and m will be, the k value will be our slope, and x is, on x-axis we will take t underscore or t half, and I will be, the intercept will be our thickness. Okay, first of all, let's calculate qt. Qt, the formula is C naught minus Ct divided by mass of the adsorbent multiplied by volume. So in this case, our reaction volume in liter was 0.01, 0.01, and mass of the adsorbent in grams was also 0.01. This means that 1 milligram per ml or 1 gram per liter. So this is equal to C naught initial concentration minus Ct multiplied by volume divided by mass. This we will log the column by putting the dollar sign before and after the column number. Before and after. Then we will drag it till the end. Or t half will be equal to square root of our time. Square root of time will give us the t half. Okay, now we will make a graph between t half and qt. We will plot this t half and qt. Let's edit this. Our x-axis value is t half, while our y-axis value is qt. Give this as intra, or you can simply write it IPD model. So we will add a trend line. We will add a linear trend line and display equation and R square value, which will give us the value of intercept and slope. Our slope is the k value 1.826, and our intercept is minus 2.06. As our intercept value or the thickness value is in minus, so this means that the R square value is 0.96. Okay. As our intercept value is in minus 2.06, this means that there are different factors which are affecting the process. So the intercept can be negative. The negative intercept can be explained by the combined effect of film diffusion and surface reaction control. So in 2008, Langmuir in his paper, he said that it can be explained by the combined effect. So this means that if your intercept value is negative, there is combined effect on the system. So it can be negative. Mostly in most of the cases, this is 0 or positive. It is passing through, the intercept is 0 or it can be positive. But if you are getting the negative value, this means that the system is controlled by the combined effect of film diffusion and surface reaction. So there is surface reaction, surface adsorption is also taking place, surface reaction is also taking place, and there is also the phenomena of film diffusion. Film diffusion I will explain in next lecture, but over here you just understand that the negative intercept value, it can be, you can get the negative intercept value, and it can be explained by the combined effect of film diffusion process and the reaction which are taking place on the surface of the adsorbent. So let's play with these. You can now add the chart elements, axis title, axis title. Our y-axis is QT, milligram per gram, while on our x-axis is T 0.5 in second or half second, T half. So now this is our IPD model. Hopefully you understand how to plot the data in IPD model and interpret the data. If you obtained negative intercept, then how you can explain that can be the combined effect of different systems. It can be due to film diffusion process and the interaction between the film diffusion process and the surface reaction. If you find these explanation helpful, please like the video and share the video with your fellow students and colleagues. Thank you very much, and Allah Hafiz. Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will discuss about radical scavenging activity measurement and IC50 calculation. First of all, radical scavenging activity, it is done using DPPH assay. DPPH is basically table-free radical which is used for the scavenging activity. We have concentration in microgram per ml from 50 to 350. Then we have controlled absorption and the sample absorption. The formula for calculating percent RSA is CA, control absorption minus SA, sample absorption divided by control absorption multiplied by 100. This will be percent RSA or percent radical scavenging activity or percent activity. So this will be equal to, let's put the formula is equal to control minus sample divided by control multiplied by 100. So this is our percent RSA. So now we get percent RSA. Now we will plot a graph between concentration and percent RSA, concentration against RSA. Go to insert, then in graph or charts, select the scatter chart. Add elements. On primary axis is our concentration or our drug concentration. In microgram per ml. While our y-axis is vertical axis is the RSA, radical scavenging activity in percent or only activity in percent. Okay. Now what we will do, we will make a trend line, we'll make a trend line, go to plus sign, trend line, then to more option, and under more option, select linear and display equation and R square value. So this is our R square value. You know, we have the formula y is equal to mx plus c. This linear form of the equation, y is equal to mx plus c. Or y is the IC50 value. Okay, y will be IC50 value. M is our slope, c is our intercept. To calculate x, x will be equal to y minus c divided by m. Over here, our m, our slope, is 0.1965. 0.1965, while our p is equal to intercept. C is our intercept. Intercept is equal to 27.347. So this will be equal to, let's copy this thing. This will be equal to 27.347. This is our intercept, the C value. So IC50 will be equal to 50. As it is IC50, so it will be 50 minus y minus c. The c value is 27.347. Y minus this value, and all of this is divided by m, 0.1965. This is our m value. So our IC50 value is 115.28. The inhibitory concentration which we need is 115. Our IC50 inhibitory concentration is at which 50% inhibition can be achieved is this value. Hopefully, now you understand how to calculate the IC50 value. In this sheet, I have the drug concentration 10, 20, 40 and 80, and we have activity as T1, T2 and T3. This is T3. This T1, T2, T3 is actually the treatments. Treatment 1, treatment 2, treatment 3, or you can also say it as these are the replicates. So we have different activities. This is another example. We have different activities of different drug concentration. Then after this, we will calculate the average of these values. To calculate average is equal to, or mean, AV average, and select those values for whose concentration you need. These are the, and then drag this one. This concentration will be, and this mean will be calculated through this way. Okay. Now, you will plot drug concentration. Let's remove this one first. Drug concentration versus mean. Go to insert. In the chart tab, select the scattered one, and then add chart element, horizontal, and add primary axis. Our primary axis is concentration. Concentration, and over here is activity or percent RSA. Percent RSA. Now make a trend line, go to plus sign, trend line, and go to more option. Over here you can see linear is selected, and then you can display the R square and equation value. So we have y is equal to mx plus c. Our m, our slope value, m or slope value is 0.4104. Our intercept or C value is 9.6087. This is intercept is 9.6087. Our IC50 value will be equal to IC50 value, or the concentration at which 50% inhibition can be done. X will be our concentration, the concentration. Y is the IC50 value, C is our intercept, and M is our slope. So this will be equal to Y is our IC50 minus intercept divided by slope value. So over here, to achieve IC50, you can see that when the drug concentration was 80, in all three replicates only 42 or 41% activity was achieved. This activity is in percent. Only 41 or 42% activity was achieved. According to the formula, the concentration is 98.41 or almost 98-99, between 98 and 99. Then 50% inhibition can be achieved. Hopefully now you understand how to calculate the IC50 activity. First of all, how to calculate the radical scavenging activity, how to measure the radical scavenging activity, and then on the basis of scavenging activity, percent scavenging activity, how you will calculate the IC50. I gave you this example in which we have concentration, absorption of the control, and absorption of the sample. Then we calculated percent RSA from this data, and then on the basis of this percent RSA obtained, we calculated the IC50 value from the linear regression equation. In some cases, you may not have a linear line, so in that case, you will have to use another model. If you need some more information, please tell me in the comment box, and don't forget to like and subscribe to my channel. Thank you, and Allah Hafiz.
How I grew the family business myself using only
QuickBooks Online.
No, Ma. I did it myself.
Tell them the truth.
Okay. It's
QuickBooks Online. With automatic invoicing and expense tracking, we can focus on growing. QuickBooks can do it. QuickBooks, behind every successful business.
Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about fitting the data in Friendlich adsorption isotherm. Before this, we fitted the data into Langmuir adsorption isotherm, and prior to that, we determined the rate of reaction of our adsorption data. Today we will fit the data in Friendlich adsorption isotherm. This is the equation for Friendlich adsorption isotherm. Log QE is equal to log KF plus 1 over N log CE. K or KF is Friendlich adsorption constant. N is the Friendlich adsorption exponent. On the basis of N, we determine that whether our adsorption process is favorable or non-favorable or less favorable. So if the value of N is equal to 1, this means that there is linear relationship. The adsorption is linear. If the value of N is more than 1, is greater than 1, this means that the adsorption process is favorable. There are more additional sites available for the adsorption. But if the value of N is less than 1, this means that it is unfavorable. Most of the sites are covered. So from this equation, we will calculate the slope and intercept. Our slope is 1 over N, while our intercept is log KF. In my previous videos, I explained how to calculate different values, the QT, QE, Qmax, So we did 7 experiments on initial concentration from 10 to 100 ppm, and at equilibrium time we calculated our CE value. If you remember, in our last explanation for pseudo first order reaction, I explained that we did the experiment till 180 minutes, and in 180 minutes 60 minutes was our equilibrium time. We calculated from there that 60 minutes is our equilibrium time for different concentration. So for all these concentration, we took 60 minutes as our equilibrium time, and at that equilibrium time we determined the CE value. In this case we use dyes, but maybe in your case it can be metal, it can be some pharmaceutical drugs or some other pollutants or some other nutrients which you are studying. So this is CE is our concentration at equilibrium time. We will calculate the log of this, log CE, and copy this formula till 100 ppm. QE is equal to, you know the formula if you have seen, if you have watched my previous videos, the QE is equal to initial concentration minus concentration and equilibrium divided by mass or weight of the adsorbent multiplied by volume of the reaction solution. Our volume was 0.01 in liters, and our mass of the adsorbent was also 0.01. This means that our adsorbent dose was 1 milligram per ml or 1 gram per liter. So the formula is initial concentration minus concentration at equilibrium multiplied by volume in liter divided by mass in grams. We'll put $ before and after this to log this value, as we will use these two values along the 100 till 100 ppm. So this is our QE value. We will take the log of this value is equal to log of QE at 10 ppm and copy this till the end. So we have log QE value and log CE value. If you see the formula, our x is log CE, so we will plot log CE against log QE, okay, to get the slope and intercept. Our log CE will be on x-axis while log QE will be on y-axis. We'll select a scatter plot. Let me give this name. Finally, adsorption isotherm. So this is our log at French adsorption isotherm. We'll add a trend line, linear trend line, and we will display the equation and R square value. This is our, we'll change the font. Okay. So from here, from this equation, you know your mx or your slope is slope is equal to 0.5391 and intercept is 0.6828. This is the intercept value. As you know from the equation, our slope is equal to 1 over n, or we can say that slope is the 1 over n value is 0.5391. So the n value will be equal to 1 divided by the slope value. So slope is 1.85. To calculate the k value, k is equal to our intercept is equal to log kf. So kf will be equal to anti-log of the intercept. So the anti-log base 10 of the intercept value. So this is kf value is 4.81. If there is more, if the kf value is higher, this means that adsorption capacity is will be more. As our n value is more than 1, so the adsorption conditions are favorable, or the adsorption process is favorable. Now we will play with this. Go to the chart design and add axis title. Primary, our x-axis is log CE, or y-axis is log QE. Remove these. Okay. You can arrange the graph. This is 0.5, 0.1, and you can add some tick marks. Major and minor outside. No need for minor, I think. Major, and it should be solid line, and the weight is okay. Now this value, let's see, the axis option is, let me begin it with 0.4 till 2 and let it be 0.1. 0.2. Okay, I think this looks good now. The major, you can include the major outside and make this automatic or black and increase its size to 1.5 and also include minor line outside. Okay. In the axis option, we can 0.08, 0.3, okay. And now this line, this can be and straight line. We can play with the markers, can increase the marker size, go to the marker option and increase its size, solid line, and the border is solid fill. So this is your Freundlich adsorption isotherm. Log CE, log QE, and Freundlich adsorption isotherm. So you will report in your thesis or in your this table an R square value. R square value is 0.95, 0.9526. So this is your R square value. When you are you will give n kf value and R square value along with this graph. Hopefully now you understand how to plot the Freundlich adsorption isotherm. Fit your data into Freundlich adsorption isotherm. If you get some idea information from this video, please don't forget to like and subscribe to my channel and share with your fellow students and colleagues. Thank you very much. Next video will come with another video tutorial of the adsorption isotherm. Allah Hafiz. Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about fitting the data into Langmuir adsorption isotherm. This is a series of lecture in which we will discuss about, we will fit the data into different adsorption isotherms. Our next lecture will be about data fitting in Freundlich isotherm. Then the other adsorption models like Hasley, GR, Thumbkin and Fromkin, all the isotherms we will discuss in this lecture series. So let's start our lecture about fitting data into Langmuir adsorption isotherm. Before going into the details how to fit the data, if you have any problem in adsorption modeling or photocatalytic modeling, then you can comment in the comment section. So we have this model data from our experiment. We did experiment on different initial concentrations from 10 up to 100. We did our experiment for all the concentration and we measured the concentration at equilibrium. Our equilibrium time was 60 minutes. So after 60 minutes, the concentration of equilibrium we find out for different concentration. Before fitting the data, you should know that the Langmuir adsorption isotherm, the equation of Langmuir adsorption isotherm is 1 over QE is equal to 1 over KL Q max. KL is the Langmuir adsorption constant. Q max is the maximum adsorption capacity, which we will calculate from this Langmuir adsorption isotherm, multiplied by 1 over CE. CE, as you know, it is the concentration at equilibrium plus 1 over Q max. So from Langmuir adsorption isotherm, we will calculate the KL value and Q max value. And we will report in our paper or in our thesis the KL and Q max value for the Langmuir adsorption isotherm beside the R square value. On the basis of R square value, we will, the same model data, we will put in other adsorption isotherm and we will see that where is best fitting. The best fitting will be determined on the basis of R square value, where we will have closer R square value to 1, that will be our best fitting. So in Langmuir adsorption isotherm, the graph will be made between, we will plot the graph between 1 over QE versus 1 over CE. So we'll make a plot of 1 over QE versus 1 over CE. Our CE value will be, 1 over CE value will be on x-axis. Okay, this will be on x-axis, while 1 over QE value will be on y-axis. Okay, so let's start the calculations. 1 over CE. One more thing, I assume that you know how to create a formula inside the Excel. If you have any problem, then you can comment in the comment section. So I will upload some videos. If you do not know how to do the calculation in Excel, then I will upload 1 to 2 videos on Excel too. But over here, I assume that you know that how to create a formula inside Excel. So is equal to 1 divided by CE. This is our CE value. Okay. Then drag this formula from till the end. Then this formula will be copied throughout. Okay. Then log CE, log CE value, and press enter. And the same, double click this one or copy the formula. Okay, copy the formula, double click this one or drag this one. This will copy the formula till the end. Okay, then ln CE is equal to, write ln and then select this ln, double click this one and it will be selected, and CE. Close the bracket and this will calculate ln CE for you, and drag this one and it will copy all the data. Okay, so now we have calculated 1 over CE, log CE and ln CE. Now we have to calculate the QE value. QE is adsorption capacity at equilibrium. The formula for calculating the QE is the formula. This is the equation for calculating the QE. QE is equal to C naught, initial concentration, minus CE, concentration at equilibrium, divided by W. W is basically, what is W? W is the mass of the adsorbent. Whatever adsorbent you have used, the mass of that adsorbent in grams. Okay, the mass of adsorbent in gram, and V is multiplied by V. V is the volume of the solution in liter. We have used 60 ml, we have used 60 gram of the adsorbent, which is equal to 0. Divided with 1000, you will get 0.06 grams as the mass of the adsorbent, and we used 60 ml of the solution, so it is 0.0. Converting the 60 ml into liter, it is 0.06 liter. Okay, so we have written all this. If you have different weight or different volume, then you can go according to that values. Okay, you can go according to that values. So the QE we will calculate according to this formula, is equal to, QE is equal to bracket C naught, initial concentration, minus CE divided by W, which is 0.06, and multiplied by volume. Okay, multiplied by volume. As over here we have 1, 2, 3. 3 brackets are closing, so we will put 3 brackets over here. And then enter. Drag this one and copy the formula till the end. Okay, one thing we forgot, as over here we have used the W value and V value. So these values will be constant throughout all concentration. So we will log these two. For logging, just enter $sign before and after the column number. This column is N. So we will put $sign before and after N, and this column is the volume column is O. So we will put $sign before and after the column sign. So this will be logged and it will be followed in all next formulas. So now drag, it will copy all this. Okay, it will copy all this. Okay, now next is 1 over QE. 1 over QE. This is our 1 over QE. Then log QE the same, log the QE value and enter. Copy the formula. Okay, now as we have gotten the 1 over QE value and 1 over CE value, so we will make a plot of these values in origin. You can use Excel also, but it is better, but it is recommended, but I recommend the origin to get the intercept and slope values. So we will copy that in Excel, in origin, Control C and Control V will delete these values which are also copied. We do not need these values. Now make a scatter plot of QE and CE. CE is our x-axis, QE is our y-axis. So this is the plot of 1 over CE versus 1 over QE. Now what we will do, we will go to the analysis section, then fitting, linear fit and open dialog. We'll make a linear fit to calculate the slope and intercept values. Okay, so press OK over here. Do not need to change anything. Press OK over here and it will give you the linear fit to you. Press OK. So over here, the linear fit, from here we got the intercept and slope values. Okay, before going to the using the slope and intercept values, let's see. You can make changes in the graph, as you will use this graph in the Word file, in your thesis or in your article. So make changes over here so that it looks better. Let's first change let's first change the symbols. For example, I want to use, you can use any of these. Let me use this one. Okay, and then I will increase its size and press apply and OK. This trend line, I want it as dotted line in black color and with OK. So now this is our plot. You can change the way it looks like. Okay. You can write text over here. For example, this is figure A. You can write it as figure A, you can select and drag anywhere you want to put this. Okay, this is A. You can write some other things also. For example, this is, you can copy the formula over here. Whatever you want to write, just press text and write over here. So over here we got the equation. This is the linear regression y is equal to mx plus c, a plus bx, plot of 1 over qe, intercept is 0.021, the slope is 0.33, the adjusted R square value is 0.99966 or 0.999997. So this is one of the best plot giving us the 0.999 values. Okay, then you can copy this plot, or you can export this plot. Okay, you can export this plot to the as a image file. Okay, you can see over here as an image file. Whenever you are exporting it, always use the PNG format. Then, for example, let's cancel this thing. So you can export it, or you can copy this page and paste it in your Word file. So now we got the values for intercept and slope values. So we will copy the intercept value and put it in our Excel file. Sorry, origin, copy this value and paste it over here. Okay, this is your intercept value. Then the slope value, copy it and paste it into the slope. Okay, now for calculating Qmax, we have the formula intercept is equal to 1 over Qmax. Intercept is equal to 1 over Qmax, while Qmax will be equal to 1 over intercept. So this will be equal to 1 divided by Qmax. 1 divided by intercept. So it will give you the Qmax value. Maximum adsorption capacity over here is 47. Okay, milligram per gram. 47 milligram per gram. Now to calculating KL value, we have the formula that slope is equal to 1 over KL into Qmax. We have the formula, this equation. Slope is equal to 1 over KL into Qmax, while our KL will be equal to 1 over slope into Qmax. So let's calculate this thing. Is equal to 1 divided by slope multiplied by Qmax. So it is 0.063. The KL value, or the Langmuir adsorption constant, is 0.06. For RL value, RL is basically the separation factor. On the basis of separation factor, this is basically the separation factor. On the basis of separation factor, we determine whether our adsorption process is favorable, unfavorable, or irreversible. Okay, so you should keep this thing in mind, that we want to know whether our process is favorable, unfavorable, or non-favorable, or irreversible. if the RL value, okay, the RL value is less than 0. If the RL value is less than 0 or in minus, then this is unfavorable. The adsorption process is unfavorable if RL value is less than 0. If it is between 0 and 1, then we say that the adsorption process is favorable. Okay, between 0 to 1, then this is favorable. And if RL value is more than 1, if RL value is more than 1, then the process is irreversible. Okay, okay. I have seen some videos, some lectures where they use only one concentration. Let's go to the formula first. The RL value, RL is basically equal to 1 over 1 plus C naught into KL. Okay, now I have seen videos and lectures where they have used one C naught value, one initial concentration. In these, one initial concentration. Basically, they use that concentration which which the authors used for the optimization of their system. For example, I used the 30 ppm in my paper, so I reported the 30 ppm value or 30 milligram per liter value and reported the RL value for this 30 milligram. But one should do the calculation for RL of RL value for all these concentration, because without determining the RL value for all these concentration, we cannot know that at different concentration how our system or how our adsorbent is responding. What are the properties of our adsorbent at lower concentration or at higher concentration? So this RL value should be concentration. So let's go putting the formula. This is equal to 1 over, let's see the formula. RL is equal to 1 divided by, we should put brackets, 1 divided by 1 plus C naught multiplied by KL. So we have started two brackets, so we will close two brackets over here. And this KL value, it will remain throughout the formula, so we will log this one. If you want to calculate this for all the concentration, we will log this one and press enter. So your RL value is okay. In this formula, I have 1 over this, 3 brackets, this. Now the formula is okay. You should be vigilant with the formula that what you are doing, what you are writing. As before this, there was no bracket over here, so one was dividing this one, 1 divided by 1, 1 plus this, all this. This is not like this, 1 over 1 plus this. These will be multiplied and then it will be added with 1 and then this will be divided. So this is our formula. And now copy this to all concentration. Now you can see the response of our adsorbent at different initial concentration. It is less than 1. It is between 0 and 1. The RL value is between 0 and 1. So this means that our adsorption process on our adsorbent is favorable. It is favorable adsorption process. Okay. Hopefully, now you understand how to calculate, how to plot the different adsorption data. So for reporting, you will report the Qmax value, the KL value, you will discuss the RL value. Okay. If you are using 50 ppm, it is also less than 1. So you can say that the adsorption process is favorable as RL value is less than 1. So you, and R square value. You can see over here the R square value is 0.996. The R square value is this one, 0.99966. Okay. So this is R square value. Whenever you are writing, you will have to determine, you will get the R square values. Okay. Hopefully now you understand that how to fit the Langmuir adsorption isotherm on your data. Thank you very much. If you have any question regarding this, you can ask me in the comment section. If you think that this video is useful for you and for other students, do like and share with other colleagues and with other students so they can get maximum benefit of it. The purpose of this is not to making a YouTube video, but to teach you that how to plot the adsorption, how to plot your adsorption isotherm. Hopefully you have learned from this, and you will like this. You will make comments and share this video. Make sure that you press the bell icons, so whenever I upload the other adsorption isotherms model and do the data fitting for that, so you can get the update regarding that. Thank you very much. Take care of yourself. Allah Hafiz.
अब जीते मौका कैश प्राइजेस जीतने का और अपने दोस्त को एक स्पेशल गिफ्ट या कोक बॉटल देने का। बस क्यूआर कोड स्कैन करके ढक्कन पर दिया गया कोड व्हाट्सएप करें। सो अपने जिगर के साथ शेयर अ कोक नाउ। कैलटेक्स हेवलिन के साथ ऑन करो जीत का हैवी सीन।
Bismillahirrahmanirrahim. Welcome to Dr. Saqib Khan Science Academy. We are discussing the analysis of the adsorption data. So we already completed some videos on first order, second order, pseudo second order kinetic model. Today we will discuss about pseudo first order kinetic model. We will use the same data which we already used for different order of reactions. We know the equation. The pseudo first order kinetic model is ln QE minus QT is equal to ln QE minus K1T. We will plot ln QE minus QT versus time, and from here we will calculate the slope and the intercept. We have the equation y is equal to mx plus c, where m is our slope and c is our intercept. So ln QE is our intercept, while minus K1 is our slope. So from here, we will calculate the slope and the intercept values, and from there we will calculate ln QE from the intercept and minus K1 from the slope. So our slope will be equal to minus K1, while our intercept will be equal to anti-ln of QE, anti-ln of the intercept. So we have this data for which we have calculated the QE. Now we are already using 30 ppm of our pollutant concentration, dye concentration, or our metal ion concentration, or some drug. So the optimum concentration we will use to find out ln QE minus QT. For calculating QE, we have the formula initial concentration minus concentration at equilibrium multiplied by volume divided by mass of the adsorbent. And same will go with the QT. So we calculated the QE through this formula. QE is equal to C naught minus CE divided by weight multiplied by volume. Or weight and volume are the same, or mass and volume are same during all the experiments, so we will take it as 1, and QE will be equal to C naught minus CE. Then we get the 30 ppm optimum concentration, and then use this concentration at different time interval. For example, over here, we did the experiment up to 120 minutes. So we have CT data, or concentration at time, at 0 to 120 minutes. Then we calculated QT. Let's calculate it here. QT is equal to C naught minus CT multiplied by volume, which is 60 ml, divided by mass, which is also 60 milligram, or 0.06 liter divided by 0.006 grams. So this QT, these two values we will log by putting $sign before and after the column. This will log these two values and drag the formula till the end. So we get the QE value. Then we already calculated our QE value, which is 19.238 over here. So we'll just put this value over here and drag it till 120 minutes. Now we have QE minus QT. This is our QE value minus QT value. And drag this value till the end. Then we'll calculate the ln of QE minus QT is equal to natural log of this value and drag it till the end. So this is our ln QE minus QT value. Now our plot will be ln QE minus QT versus time. So we'll copy these two values. We'll copy these two values over here and all these values into the origin. Now we will make a scatter plot of these values. This is a scatter plot. We'll go to the analysis section. Then we'll make a linear fit of this data. So by linear fitting, we got the values of slope and intercept. Let me copy this table to Excel So we have the values of intercept and slope. So our intercept value is this one, and we will copy our slope value. We'll copy our slope value. Now we can calculate the QE calculated value, K1 value, and R square value. Adjusted R square is this one. So we'll copy this over here. This is our adjusted R square value. Now we have to calculate QE and K1 value. As our intercept is equal to ln QE, while our QE will be equal to anti-ln of the intercept. So anti-ln of the intercept, EXP of the intercept. So this is our calculated QE value, while our experimental QE value was 19.238, and this is our calculated. K1 is equal to, from the equation, as we know that our slope is equal to minus KT. So our K1 will be equal to minus slope. So this will be equal to ABS, to convert it to the neutral value as it is in minus. So ABS of the slope. So our K1 value is 0.027. Our QE value is 28.113. So over here, we know that from this equation, we calculate our QE calculated and the K1 value. Hopefully now you understand how to calculate, how to fit the data into the pseudo first order kinetic model. We have R square value, we have K1, we got the QE value. Now come to the graph and make it a presentable graph. So this is our pseudo first order kinetic model. Pseudo first order kinetic model. This is our linear fit. We can change these. We can increase its size to, let's see, 12. And we can also increase its size to 3. We can play with it to make it a presentable data. This is time in minutes. So you can copy this data into your Word file or your thesis, wherever you want. So this is your first order kinetic model. Thank you very much. Don't forget to comment, subscribe, and like the video. Please share it with your colleagues and your students to get maximum of it. And if there is any mistake during calculation or during interpretation of the equation, any other of my videos, please let me know so I can update that mistake. Thank you and Allah Hafiz. Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about measurement of concentration from absorption data. If you have absorbance data, then how you will calculate the concentration. But before going to measurement of concentration, you should have your calibration curve or calibration data. Then from that data, you can calculate the absorbance data. We have two methods. We will discuss two methods over here. One is the trending method. On the basis of trend, you will calculate the absorption data. And the other one is from the calibration curve. Let's first discuss the concentration measurement from the absorbance based on the trend. For example, we have absorbance of unknown as 1.8. This is my absorbance. I have a sample whose absorbance I calculated it is 1.8. Now how we will calculate the absorbance is equal to, just write trend, select this trend, select the concentration first, then comma, then select the absorbance, comma, and then select the absorbance of the unknown. This will give you the concentration of this much absorbance based on this data. For example, if we have another absorbance 0.952, this absorbance, so this will be equal to trend, select the trend, get the concentration value, comma, get the absorbance value, select the absorbance value, comma, and select the absorbance of the unknown. Close the bracket and enter. So 0.952 is for the absorbance 0.952, the concentration will be equal to 19.43. You can see over here for 20, the absorbance is 1.0. For 19.43, the absorbance is 0.95. It makes some sense. This is the simple one. That on the basis of trend, how you will calculate, how you will measure the concentration. A simple formula, I will write this one in the description. Trend, concentration, comma, absorbance range, then comma, and then select the absorbance of the unknown. This is one. The other one is select these two, go to insert, go to make a scatter plot, make a scatter plot, then add chart elements, primary, and the primary horizontal and primary vertical. On horizontal line, we have concentration in milligram per liter or in ppm, while on the y-axis, we have absorbance, arbitrary unit. Okay, now what we will do, we'll make a trend line, and over here select the linear one, display the equation on the chart and display the R square value. So this will give you y is equal to mx plus c. M is our slope, c is our intercept. So our slope is equal to 0.
शेयर कोक वाली बोतल से क्यूआर कोड स्कैन करके ढक्कन पर दिया गया कोड व्हाट्सएप करें और जीते स्पेशल गिफ्ट्स।
0.383. Our C value or intercept value is 0.2084. Okay. Y is our absorbance, and X is our concentration. As we have the formula y is equal to mx plus c. So our x will be equal to y minus c divided by m. This is simple formula, simple mathematical formula. If y is equal to mx plus c, when c will be equal to on the other side, so it is plus c, over on the other side it will become minus c, y minus c, and if m is multiplying over here on the other side, when it will go, it will be divided by y minus c. So our x will be equal to y minus c divided by m. Y is our absorbance, c is our intercept, m is our slope. So for example, our absorbance is 1.8. Let's reconfirm that this one, the one which we calculated from the trend line, our absorbance, if our absorbance is 1.8, what will be our concentration? Is equal to, put the formula, y minus c is the intercept divided by m value. So it is almost 41.55, 41.56. Okay, converted into numbers. Convert this one into numbers also. So both are almost same. So you can say that using this equation or using this equation, both are same. Y is equal to mx plus c. We have calculated it from y is equal to mx plus c, and we have calculated it based on the trend, concentration data, range of concentration, range of the absorbance, and the absorbance of the unknown sample. This will give you on the basis of trend, it will convert the absorbance into the concentration. This one is much simpler one as compared to this. But you can recheck this data according to the trend line or according from the regression equation. Hopefully now you understand how to calculate the absorbance using the trend and using the regression equation. Hopefully now you understand how to measure the concentration from the absorbance data. If you get some information from this video, don't forget to subscribe to my channel for more videos like this. Like and share the video with your other colleagues so maximum people can get benefit from it. Thank you and Allah Hafiz. Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about point of zero charge, how to measure the point of zero charge experimentally, and then how to plot the point of zero charge and measure the point of zero charge from the experimental data. Point of zero charge are also known as isoelectric point. Iso means same, the point at which the charges on the surface of material become zero. It is property of a material or any surface where it has no net charges, no net surface charges. When the charges on the surface becomes equal to zero, then that point is called as point of zero charge. The point at which the surface of any material becomes electrically neutral. This means that it has equal number of positive charges and negative charges. Then we call that point as point of zero charge. It is an important parameter in environmental sciences and in chemistry that we determine the point of zero charge for our adsorbent or our nanomaterial, so we can fully understand or we can fully design our experiment according to the property of our material. There are different methods to measure the point of zero charge. Today in this video, I'll share you the salt addition method. For the salt addition method, the salt which we will use is sodium chloride NaCl 0.1 molar NaCl solution. If you don't know how to prepare 0.1 molar solution, you can weigh approximately 2.922 grams of NaCl and then you can add it to 500 ml distilled water. After this, we will take 11 different flasks and labeled them with as pH2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. You can reduce the number of flasks by changing the pH from 2, 4, 6, 8, 10, 12 like this or as you wish. But when I did the experiment, I took all the pH values for more accurate result. Then we will add 30 ml of 0.1 molar solution to each of these flasks and adjust the pH of these flasks according to their labeling. So for pH2, we will adjust the pH at pH2. For pH3, we will adjust the pH at pH3 and same goes to pH12. After adjusting the pH, we will add 30 milligram of our adsorbent of our nanomaterial to each of the flasks. Then we will agitate these flasks in shaking incubator. Normally, we run it at 150 RPM revolution per minute for 24 hours. And then after 24 hours, we will filter this out and the filtrate collected, we will measure the pH of our filtrate. Then we will calculate delta pH. Initial pH, which we already know, the final pH of each flask. For pH2, for example, initial pH is our pH2. If the final pH is increased or decreased, so we will write that pH. So delta pH we will calculate and then we will plot it. Let's go to the Excel sheet and see the results and how to plot delta pH. This is the initial pH of our flasks 2, 3 up to 12 and this was the final pH after 24 hours of experiment. Now we will calculate the delta pH is equal to, as the formula says, initial pH minus final pH or after 24 hours. So this is our delta pH. We'll copy this data till the end and now we'll plot a graph. So from here, our initial pH will be on x-axis while delta pH will be on y-axis. So we'll go to the insert chart menu. We'll select the line scattered plot. So from here, now we will calculate the point of zero charge. Point of zero charge is basically the point from where it crosses the x-axis. From it, where it crosses the x-axis. So we'll adjust this and major unit we can change it as 1 and this one also 0.1. Okay, now we'll go to the tick mark and minor is outside and major outside. Then from here, we'll select the color of the line as black and increase the size of our graph to get more real picture. So you can see over here that it crosses at 5.7, 5.6 or 5.7. It crosses the x-axis at 5.7. So our PZC value or point of zero charge value is 5.7. So at this pH, at the pH of 5.7, our material will have zero charge on its surface. Now as we calculated the PZC value, and we know that at pH 5.7, if the solution pH is 5.7, then there will be no charges on the surface of our adsorbent. But if the pH is higher or pH is lower, what type of charge will be on the surface of the adsorbent? If the pH of the solution is less than the PZC value, If we put our adsorbent in a solution or in a dye solution or in a metal solution whose pH is less than the pZc value, then there will be more positive charges. Then there will be more positive charges on the surface of our adsorbent. But if the pH of our solution is higher than the pZc value, then the charges on the surface of our adsorbent will be negative. More positive charges will be attracted towards the surface, towards our nanomaterial. Hopefully, you understand this. If there is still any problem, you can tell me in the comment section. I'll try to explain it in more detail. Thank you very much. If you got some information from this video, then please like, share and subscribe to my channel. Thank you and Allah Hafiz. Bismillahirrahmanirrahim. Assalamu alaikum and very warm welcome to Dr. Saqib Khan Science Academy. आज हम सूडो फर्स्ट ऑर्डर काइनेटिक मॉडल के बारे में बात करेंगे कि अपना एड्सॉर्प्शन का डेटा सूडो फर्स्ट ऑर्डर काइनेटिक मॉडल के अंदर किस तरीके से फिट करेंगे। इससे पहले मैंने सूडो फर्स्ट ऑर्डर काइनेटिक मॉडल की वीडियो बनाई जो कि इंग्लिश में थी। पे आज मैं सूडो फर्स्ट ऑर्डर या PFO काइनेटिक मॉडल को उर्दू और हिंदी में एक्सप्लेन कर रहा हूँ। सूडो फर्स्ट ऑर्डर काइनेटिक मॉडल के लिए हमने एक कंसंट्रेशन का एक्सपेरिमेंट रन किया था। उस कंसंट्रेशन के एक्सपेरिमेंट की बेस पे 30 ppm ऑप्टिमम कंसंट्रेशन चूज की थी, जो कि हमने बाकी एक्सपेरिमेंट्स के लिए, डोज के एक्सपेरिमेंट के लिए, पीएच के एक्सपेरिमेंट के लिए और इसी तरीके से टेम्परेचर के एक्सपेरिमेंट के लिए ये कंसंट्रेशन जो है वो हमने 30 ppm या 30 मिलीग्राम पर लीटर की कंसंट्रेशन यूज की थी। अब यही जो ऑप्टिमम कंसंट्रेशन है उसकी हमने CE वैल्यू निकाली थी और QE वैल्यू निकाली थी। अगर आपको CE वैल्यू की कैलकुलेशन नहीं आती, हाउ टू डिटरमिन और हाउ टू मेजर द CE वैल्यू, तो मैंने एक वीडियो इसके ऊपर बनाई हुई है। आप उस वीडियो को जाके चेक कर सकते हैं। लिंक डिस्क्रिप्शन में भी दिया हुआ है और यहाँ पे भी लिंक दिया हुआ है। इसकी हमने एक्सपेरिमेंटल QE वैल्यू निकाली है। सूडो फर्स्ट ऑर्डर काइनेटिक मॉडल की हमारे पास इक्वेशन है ln QE माइनस QT इज इक्वल टू ln QE माइनस K1T। K1 हमारे पास सूडो फर्स्ट ऑर्डर काइनेटिक मॉडल कांस्टेंट है। QE हमारे पास एड्सॉर्प्शन कैपेसिटी एट इक्विलिब्रियम है और QT एड्सॉर्प्शन कैपेसिटी एट टाइम। ये जो 30 ppm की ऑप्टिमम कंसंट्रेशन हमारे पास आई थी, इसका हमने एक टाइम एक्सपेरिमेंट रन किया है 120 मिनट्स तक। आप कम भी कर सकते हैं, आप ज्यादा भी कर सकते हैं upon the property of your material। उसकी हमने कंसंट्रेशन एट डिफरेंट टाइम इंटरवल मेजर की है। अच्छा, इक्वेशन की तरफ आते हैं। इक्वेशन हमारे पास स्ट्रेट लाइन इक्वेशन है और लीनियर फॉर्म ऑफ दी सूडो फर्स्ट ऑर्डर काइनेटिक मॉडल है। y is equal to mx plus c। mx हमारे पास K1T है और c हमारे पास ln QE है। मतलब हमारा इंटरसेप्ट जो होगा वो हमें ln QE की वैल्यू देगा, जबकि जो स्लोप होगा वो हमें K की वैल्यू देगा और K1 की वैल्यू देगा। x हमारे पास t है और y हमारे पास ln QE माइनस QT है। तो हम ln QE माइनस QT वर्सेस टाइम एक ग्राफ प्लॉट करेंगे और उससे हम स्लोप की वैल्यू और इंटरसेप्ट की वैल्यू जो है वो वहां से हम निकालेंगे। ठीक है, तो फर्स्ट ऑफ ऑल हमारे पास QE की वैल्यू, जो एक्सपेरिमेंटल QE है उसकी वैल्यू हमारे पास है 19.238। ठीक है, इसको हम कॉपी करते हैं और ये एक्सपेरिमेंटल QE वैल्यू यहाँ पे हम डाल देते हैं। ठीक है, QT मेजर करने के लिए हमारे पास इक्वेशन है QT इज इक्वल टू C0 माइनस CT मल्टीप्लाइड बाई वॉल्यूम डिवाइडेड बाई मैस। मैस और वॉल्यूम हमारे पास दोनों सेम थे, तो इसलिए फार्मूला में हम वही सेम वैल्यू रखेंगे। इन योर केस, आपके केस में ये डिफरेंट भी हो सकते हैं, तो उस लिहाज से आप इसको फार्मूला में पुट करें। इज इक्वल टू C0 माइनस CT multiplied by volume is 0.01 in liter divided by mass which is also 0.01 ये हमारे पास QT की वैल्यू आ गई। अच्छा, अब इसको हमने नीचे कॉपी करना है, तो इन दो वैल्यूज को, क्योंकि हम आगे इन दो वैल्यूज को हर टाइम इंटरवल के साथ यूज करेंगे, तो कॉलम के आगे और कॉलम नंबर के बाद जो है वो डॉलर का साइन डाल देते हैं। इससे ये कॉलम्स जो हैं वो लॉक हो जाते हैं और आगे हम पूरे फार्मूले में ये कॉपी हो जाएंगे। ड्रैग करें इसको और ये पूरा फार्मूला QT का, जो ये वाला फार्मूला है QT का, ये आगे कॉपी हो गया। अब QE माइनस QT, क्योंकि हमारे पास यहाँ पे इक्वेशन में ln QE माइनस QT है, तो पहले हम QE माइनस QT फाइंड आउट करेंगे और फिर उसका ln लेंगे। QE माइनस QT, ये हमारे पास QE माइनस QT की वैल्यू आ गई। इसको ड्रैग करें और ये सारी वैल्यूज जो है वो कॉपी हो गई। अब हम इसका ln लेंगे, इज इक्वल टू ln लिखें और इस वैल्यू का ln, इस वैल्यूज को कॉपी करें। अब हमारे पास ln QE माइनस QT की वैल्यू भी आ गई है, हमारे पास टाइम की वैल्यू भी है। तो x एक्सिस पे हम टाइम लेंगे और y एक्सिस पे हम ln QE माइनस QT। एक्सेल में इंसर्ट में जाएं। ये डेटा आप ओरिजिन में भी इसको प्लॉट कर सकते हैं और यहाँ पे भी कर सकते हैं। मेरी जो पहली वीडियो है जिसमें सूडो फर्स्ट ऑर्डर काइनेटिक का मॉडल एक्सप्लेन किया हुआ है इंग्लिश के अंदर, वहां पे आप देख सकते हैं कि मैंने ओरिजिन के अंदर इसको किस तरीके से प्लॉट किया हुआ है। यहाँ पे मैं एक्सेल में ही प्लॉट करूंगा, तो स्कैटर प्लॉट की तरफ आए और एक स्कैटर प्लॉट, स्कैटर प्लॉट प्लॉट कर दें। यहाँ पे प्लस के साइन पे आए और ट्रेंड लाइन इसमें ऐड करें। मोर ऑप्शंस पे जाएं। लीनियर ऑलरेडी सिलेक्टेड है, सिर्फ आपने इक्वेशन और आर स्क्वायर वैल्यू की को सिलेक्ट करना है कि इससे हमारे पास आर स्क्वायर की वैल्यू और इक्वेशन की वैल्यू जो है वो आ जाएगी। सो हमारे पास mx y इज इक्वल टू mx प्लस c की वैल्यू जो इंटरसेप्ट है हमारे पास, इसकी वैल्यू है 3.37337 और स्लोप की वैल्यू है माइनस 0.0271। ये हमारे पास स्लोप की वैल्यू आ गई। अब यहां से हम स्लोप QE और K की वैल्यू जो है वो फाइंड आउट करेंगे। R स्क्वायर की वैल्यू जो है हमारे पास है 0.8561। हमारे पास इंटरसेप्ट बराबर है, इक्वेशन में अगर आप देखें तो इंटरसेप्ट इज इक्वल टू, इंटरसेप्ट ln QE के बराबर है और स्लोप K1 के माइनस K1 के इक्वल है। इंटरसेप्ट इज इक्वल टू ln QE, तो हमारे पास QE के बराबर होगा एंटी लॉन ऑफ इंटरसेप्ट, और जब हम एंटी लॉन ऑफ द इंटरसेप्ट लेंगे तो एक्सपोनेंट EXP एक्सपोनेंट इंटरसेप्ट का लेंगे तो हमारे पास QE की वैल्यू जो है वो आ जाएगी विच इज 28.13। तो हमारे पास एक्सपेरिमेंटल वैल्यू आई है 19.28, वाइल जो कैलकुलेटेड वैल्यू है, कैलकुलेटेड और थ्योरेटिकल वैल्यू जो है वो 28.18। K1 स्लोप से हम निकालेंगे, स्लोप इज इक्वल टू माइनस K1। इसके आप अगर माइनस हटा दें तो स्लोप इज इक्वल टू K1 की वैल्यू। ठीक है, तो K1 हमारा स्लोप आ गया इज इक्वल टू दिस वैल्यू। तो ये आपके पास स्लोप की वैल्यू आ गई। इंटरसेप्ट हमने कैलकुलेट किया और स्लोप कैलकुलेट किया और वहीं से हमने QE और K1 की वैल्यू जो है वो फाइंड आउट की। अपने थीसिस के अंदर और अपने मैन्युस्क्रिप्ट के अंदर एक तो आप ग्राफ, और दूसरा जब डिफरेंट ऑर्डर ऑफ रिएक्शन को आप कंपेयर करेंगे तो वहां पे QE की वैल्यू, K1 की वैल्यू और मोस्ट इम्पॉर्टेंटली R स्क्वायर की वैल्यू जो है वो आप डिस्प्ले करेंगे। R स्क्वायर की वैल्यू के ऊपर आपकी सिलेक्शन होगी कि कौन सा ऑर्डर ऑफ रिएक्शन जो है वो इसको फॉलो कर रहा है। होपफुली अब आपको समझ आ गई होगी कि किस तरीके से सूडो फर्स्ट ऑर्डर काइनेटिक मॉडल को प्लॉट करते हैं, कौन सा डेटा उसमें यूज होता है और उसकी क्या इक्वेशन है, उसको कैसे इक्वेशन में कौन कौन सी चीजें लेके हम प्लॉटिंग करेंगे और उस प्लॉटिंग की बेस पे कैसे इंटरसेप्ट और स्लोप निकालेंगे और वहां से QE और K1 की वैल्यू कैलकुलेट करेंगे और फिर R स्क्वायर की वैल्यू किस तरीके से कैलकुलेट करेंगे। थैंक यू वेरी मच। अगर आपको ये वीडियो अच्छी लगी, यहाँ से आपने कुछ गेन किया है, तो इस वीडियो को लाइक जरूर कीजिएगा, शेयर करें अपने दोस्तों के साथ, अपने कोलीग्स के साथ, और चैनल को सब्सक्राइब करना मत भूलिएगा। बेल आइकन पे क्लिक कर दें कि इस तरीके की और वीडियोस जब मैं अपलोड करूं तो आपके पास नोटिफिकेशन आ जाए। अगेन थैंक यू वेरी मच एंड अल्लाह हाफिज। Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about thermodynamics parameters. These are those thermodynamic parameters which are obtained during the effect of temperature study. We did experiments on different temperatures, 30 degrees C, 40 degrees C, 50 and 60 degrees C. We know about our initial concentration and then final concentration or concentration and equilibrium we obtained from those experiments. As our contact time was optimized for around 1 hour, so we did all these experiments of the temperature on those 1 hour contact time. After 1 hour, we obtained the CE or concentration and equilibrium. Van 't Hoff equation will be used to determine different thermodynamic parameters. The Van 't Hoff equation is ln Kd is equal to minus delta H over RT plus delta S over R. Kd is our adsorption equilibrium constant, which we will obtain through this formula, that is Kd is equal to QE over CE. Delta H is our change in enthalpy or the total energy or heat present in the system, that is delta H. R is our universal gas constant, while T is our temperature in Kelvin. Delta S is change in entropy. It is basically delta S on the basis of which we will calculate the disorder or randomness in the system. If our delta S value is greater than 0, then this means that the reaction will lead to increase in entropy and the reaction is favored in the direction that increases disorder. This means that there will be more disorder. More disorder means that the amount of energy present in the system, that amount of energy which is unavailable to do work, okay, that is unavailable, that is our entropy. So if delta S is greater than 0, this means that more energy is unavailable for the system or for the reaction. If delta S is less than 0, then the reaction lead to decrease in entropy, or there will be less randomness or less disorder, or there will be less or decreased disorder in the system. More energy will be available for the reaction. Then from delta H and delta S, we will calculate the delta G, or this is also called as Gibbs free energy. Gibbs free energy is the free energy which is present in the system or in the reaction. If our delta G value is negative, this means that the system is releasing energy, which means that the system input. So on the basis of delta G or Gibbs free energy, we determine whether our system is spontaneous or non-spontaneous, whether it is endothermic or exothermic. If the system is called spontaneous when there is no need for any input of energy. This means that the reaction can run naturally. If the delta G value is positive, this means that we will provide some input energy to the system for the reaction to be taking place. That is called as non-spontaneous reaction. From Van 't Hoff equation, we will calculate the delta H and delta S, and then from delta H and delta S, we will calculate the Gibbs free energy. So this is our Van 't Hoff equation. Ln Kd is equal to minus delta H over RT plus delta S over R. You can see over here, this is normal linear plot equation. Y is equal to mx plus c. This is our mx and this is our C. This means that we will plot a graph between ln KD and 1 over T. Our 1 over T will be on x-axis, and ln KD will be our on y-axis. Then from the slope we will calculate delta H, and from the intercept we will calculate delta S. Our slope will be equal to minus delta H over R, while our intercept will be equal to delta S over R. R is the universal gas constant. And then delta H minus D delta S, we will calculate the Gibbs free energy. Let's go to our data and play with our data. The temperature 30, 40, 50, 60, we will convert it into Kelvin. So is equal to the temperature plus 273. And double click this one. This will convert all the temperatures to Kelvin. Then 1 over T, 1 divided by the temperature which we calculated in Kelvin, that will be our 1 over T. As our CI is in milligram per liter, we will convert the CI into mole per liter. For converting mole per liter, we will convert CI into gram per liter, and then from gram per liter, that gram per liter we will divide it with the RO16 molecular weight to get mole per liter. So the formula is equal to milligram per liter divided by 1000. This is now gram per liter, then again divided by the molecular weight. So this is the CI in mole per liter. Okay. In this formula, we will log this value and then copy this formula. The same we will do for CE, that is equal to milligram per liter divided by 1000 again divided by the molecular weight of our dye or our compound. Okay. So the QE will be equal to, as our weight and volume was 0.01, while our mass was also 0.01. So to convert QE, initial concentration CI minus final concentration multiplied by volume divided by weight. And these values we will log. We'll log these values, as we will be using these values throughout the formula, so we'll log these values. Then press enter. And let's convert this number. Okay. So this is our QE value. Now this QE now we will calculate the KD. KD, which is equal to QE over CE. As you can see over here in the formula, KD is equal to QE over CE. So this will be equal to QE divided by the CE value. So this is our QE over CE value. Then we will calculate ln ln of the KD value and copy this formula. Okay. Now we will plot 1 over T versus ln KD. As in the equation we have ln KD on y-axis and 1 over T on x-axis. So we will plot this. We will plot a scatter chart. And you can see over here, this is our ln KD. On x-axis we have, this is our thermodynamics parameters. So let's change it into thermodynamic parameter or thermodynamic study, whatever you would like. So as we obtain these values, on x-axis is 1 over T, on y-axis, let's add the chart title. This is 1 over T, 1 divided by temperature, and this is our ln KD, ln KD. Now we will add the trend line and go to more options, linear trend line, and display the equation and display the equation and R square value. Let's check those one. So over here we obtain the R square value and slope and intercept value. So our slope value is minus 3986.9, while our intercept value is 13.821. So if you see, we'll calculate our delta H from the slope. We'll calculate our delta H from the slope, while intercept delta S over R. So our delta H will be equal to, if we convert this formula, delta H will be equal to minus slope into R. So this will be equal to minus into slope value multiplied by as it is the universal gas constant, it is in joule per mole, so we will convert it into kilojoule per mole. So it will be equal to 8.314 divided by 1000. Divided by 1000 to convert it into kilojoule per mole. So this is our delta H value. As we have minus sign in the slope is equal to minus delta H over R, so that's why we multiplied it with minus, as minus is already present over here. Our delta S value will be equal to intercept into R. So this will be equal to intercept multiplied by R value 8.314 divided by 1000 to convert it into kilojoule. So our delta S value is 0.11, while delta H value is 33.14. So now we can calculate the delta G value. Delta G is equal to delta H minus T delta S. So this is equal to delta H minus the temperature into delta S value. So this is our Gibbs free energy at temperature 30 degree C or 303 degree Kelvin. We will log these values. Log this value, delta H value, and log the delta N value. Delta S value. These values we will use while we will change only the temperature value. So our system at different temperature 30, 40, 50 and 60 degree C, the delta G value is in minus. If the delta G value is in minus, this means that our system is spontaneous system. Reaction with a negative delta G value, delta G release energy, which means that they can proceed without energy input. When they release energy, this means that it is an exothermic reaction and we do not need to provide any energy input. While positive delta G value is non-spontaneous and we need to provide them with the energy endothermic reaction. Hopefully now you understand how to calculate the thermodynamics parameters if you have the temperature value and initial and final concentration value. If there are any issues, you can tell me in the comment section below. If you think that the information provided in this video are helpful, then please like the video, share with your colleagues and with your students, and don't forget to subscribe the channel for more informative videos like this. Your likes and subscription shall motivate me to create more informative contents like this. Thank you very much and Allah Hafiz. Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan's Science Academy. In this series of lecture, we are discussing the adsorption kinetics or the adsorption data analysis. Before this, we did the kinetics to determine the rate of reaction. We did the PFO, PSO, pseudo first order, pseudo second order, first order, and intraparticle diffusion isotherms. Then after that, we analyzed our data and plotted the Langmuir model, Freundlich isotherm model, and today we will discuss about Dubinin-Radishkovich DR isotherm model. Basically, the DR isotherms model it tells us about the sorption energy or apparent energy of the adsorption and desorption process. Moreover, on the basis of energy, we can say that if the energy or the apparent energy of sorption is very low, then on the basis of that we can say that it is a physiosorption reaction. And if the energy obtained after plotting the model, after plotting the data and analyzing the model, if the apparent energy of sorption is high, then we can say that the process is chemosorption. So this is the nonlinear equation of the DR model. QE is equal to QM exponent minus K epsilon square. Minus K is basically the DR constant. Epsilon is adsorption potential. This is adsorption. Epsilon is adsorption potential. While QM and QE, you already know that QE is adsorption capacity at equilibrium and maximum adsorption capacity is QM. The linear form of this model is ln QE is equal to ln QM minus K epsilon square. So, Y is equal to mx plus C. Our M value will be equal to minus K. Minus K will be our slope and ln Qm is our intercept. So from the intercept we will calculate the ln Qm and from the slope we will calculate the minus K value. Epsilon square as I told you that it is the adsorption potential, and it shall be calculated through this formula. Epsilon is equal to R. R is the universal gas constant, whose value is 8.314 joule per mole per K into T. T is our temperature. This temperature we will take it in the Kelvin into 1 plus 1 over CE. And our energy will be equal to 1 over 2K. We will calculate K from the model, from this model, from this equation, and then from there we will calculate the apparent energy of absorption. So, in our experiment, the same data which we used in Langmuir and French adsorption model, the same data we will use over here. C naught is our initial concentration and CE is our concentration and equilibrium. As our concentration is in ppm or in milligram per liter, so we will convert these into mole per liter. As our energy or final energy or the universal gas constant value is in mole, and the energy is also in mole, kilojoule per mole, so we will convert these values into mole per liter. So for converting into mole per liter, as it is, mole is the molecular weight in grams in 1000 ml or in 1 liter. 1 mole is basically defined as the gram or molecular weight. The unit of molecular weight is grams per mole. So our value is in milligram. We will convert it into grams, and then we will convert it into moles. So for converting in this value into grams, first of all, C naught. For converting this value into grams, just simply divide this with 1000, as 1 grams consists of 1000 milligrams. And then converting this value, the grams, into moles, gram per liter into moles per liter, we will divide it with the molecular weight of our pollutant. In our case, we used reactive orange 16 dye, RO16 dye, so we will divide it with the molecular weight of the reactive orange 16. If you have some drug, you should know the molecular weight of that drug. If you are using some metal, you should know the molecular weight of that metal. So you will divide this, divide to convert into mole per liter. You will divide that value to milligram. That you will divide that value with the molecular weight. So this is our C naught in moles per liter. This value we will lock over here, so we could use it throughout over here. Okay, so you can see that our D20 value is appearing in all the concentration. Same we will do with the CE. So the value is in milligram divided by 1000 to convert it into grams, and then again divide this value with the molecular weight of our pollutant, our drug, pharmaceutical drug, or our metal, or any nutrient which you are absorbing. So this is our CE value. This is our CE value. QE, you already know how to calculate QE value. QE is equal to C naught minus CE divided by W multiplied by volume. W is our mass of the adsorbent and V is volume of the reaction solution. Volume is in liter, while mass or W is in gram. I have mass is in gram, so we used 1 milligram per ml, so it is 0.01 gram and 0.01 liter. So you will simply C naught minus CE multiplied by volume divided by mass or weight. Okay, these values we will log these values. If in your case mass and volume is different, mass and volume is different, then you will use that values. Over here, mine is same, so I'm using the same values. So this is our QE. Okay, over here you can see that y is equal to MC intercept. So our epsilon square will be on x-axis while ln QE will be our y-axis. So to calculate ln QE, ln of QE value. So this is our ln QE value. We will drag this one and to calculate ln QE. R value, as I told you, that it is 8.314 joule per mole per Kelvin. As the temperature is in Kelvin, our temperature was 22 degrees C. 22 degrees C, so we will convert this into is equal to convert this 22 into Kelvin plus 273.15. So this is our, we'll drag these values till the end. Now, as you know that to calculate epsilon over here, the adsorption potential, we have the R value, we have the T value, but we will calculate the 1 over CE value. So that's why over here I have written down the 1 over C. So this will be equal to 1 divided by the CE value, the one which we converted into mole per liter, we will use that value. So 1 over